Okay, so today I'd like to discuss about the timing diagram of different instructions. So I have several examples, like what will be the timing diagram of move A comma B instruction, or what will be the timing diagram for MVI related instruction like MVI A comma some data bytes, or in instruction, or for STA related instruction, STA some memory location. So the different timing diagram that will be discussed now. Okay, so first one is the timing diagram for move instruction. Move, MOV A comma B. Now all of you know that any move instruction, whether it is a move A comma B or A comma C or A comma D, or all the possible combinations of using 7 programmable registers. So in case of any move instruction, if it is related to register operation, then it's a 1 byte instruction. That means it has a particular machine code that will be stored in some memory location. So that means it has one hex code, one machine code. Okay, and if that machine code, it is fetched by the processor from a predefined locations, from a predefined location, then only the execution of that machine code, it signifies that the function of a particular instruction. Okay, now it is depends on the opcode whether you need any another operand cycle or any other machine cycle or not. So as per the last discussion, the machine cycles, it is very important in timing diagram. So for every instruction, the first machine cycle will be opcode fetch machine cycle. Okay, whether it's a 8-bit 1 byte instruction or 2 byte instruction or 3 byte instruction, the first machine cycle will be opcode fetch for every instruction. Now that opcode fetch, maximum time it requires 40 states to execute, or for certain exceptional instructions are there which needs more than 40 states to perform the opcode fetch machine cycle. Okay. So here in this case, move A comma B, it has one machine code or one hex code. And so the meaning of this one is move the content from B register to A register. And the machine code for move A comma B, right now I can't remember that particular machine code. So if I think it may be for move A comma B, maybe it is 78, I think so. 78. So the meaning of 78 is the same, that is the move the content from B register to A register. Okay, one thing you have to remember, you don't need to remember the hex code or machine code for every instruction. It is not in your syllabus. You just understand what is the function of that instruction. Okay, do not need to remember the machine code for each instruction. Okay, it is not mandatory. So assume, so if this 78, assume this 78, it is stored in some memory location 8000. So move A comma B, it is stored in 8000 memory location. It's a 1 byte instruction, so it needs one memory location to store the 78, which is the opcode or the machine code of this instruction. Now if 78 is fetched and executed by the processor, the function of this instruction will be performed. Okay, do you need another machine cycle? No, because the meaning of 78 itself, move the content from B register to A register. Okay, so you don't need to add anything or you don't need to perform anything extra. So you need in this case only opcode fetch machine cycle. If your opcode is being fetched by the processor and it is executed, then this function will be performed, because it no operand is separately given into your instruction, no memory location is specified into your instruction, so it is registered to register operation, and operand is specified into your opcode. So here only opcode fetch machine cycle is required, no other machine cycle is needed. So that's why to perform the opcode fetch machine cycle you need 40 states. So that's why this is a 1T state, the second T state, then third T state, it's a 40 states. Now the address line will be drawn in this way as per our last discussion. It will be same for all instructions in this way, and at first UART state, if it is ALE signal is high, at that time the address will be transferred. Now in this case, if you have pen and paper with you, you can write it down that assume move A comma B, it is stored in 8000 memory location. Okay. So what will be the memory address for this instruction? This will be here, this will be 00 and this will be 80. I need to share another word file. So it is written in this way. In this memory location, what is stored? Move A, comma B. That means which means 78. Okay. So in this case, the memory location is 8000, and how this memory location will be transferred? It will be transferred through the address bus. Lower order address will be, the lower order bits will be 00, and upper 8-bit address will be as 80, and that will be transferred through the buses here. So it will be 00 and this will be 80. So at first T1T state, the address will be transferred through this bus. Now when this ALE signal goes low, okay, as well as when this address bus is transferred, at the same time your operation status will be uh, given in this way. The three signals, the combinations of these three signals will be 0 1 1, because it is an opcode fetch machine cycle. So already I have given the table which status is referred by which combinations. So you must follow that table so that you can understand what is going on over here. So IO/ember 0 1 1, because it is an opcode fetch machine cycle, that's why the combinations are in this way. And at T1T state, no control signal is needed, because no control signal is required to transfer the address. Okay, control signal is required to either read or write operation. Now when this read or write operation will be performed? After getting the address. So when this address is transferred, then ALE signal goes low, and when this ALE signal goes low, that means this multiplex bus is used, that can be used now as data bus. Okay, so at that time when your data bus is ready, your control signal should be activated. It's a low level signal, so at that time it will be activated, and when this read bus signal gets activated until it is high again, the read operation will be performed and it is send the data from that particular memory address to this data bus, through this data bus, and the required number of data will be read by the processor. Okay, and that read operation will be always performed in this position, middle of T2 to middle of T3. After that it will be decoded and executed. Okay, at that time when it is decoded and executed, no address or data bus is needed because these buses are already used. You have to store it in somewhere else. Where it will be stored? It will be stored at the instruction register and instruction decoder circuit. At that time you don't need the address bus and data bus. That's why address bus is given at the last cycle, T4 T state. It is unspecified, and at that time it is given the dotted line signal. Okay, and rest of the signals will be remain same. So this is the timing diagram of move A comma B instruction. Assume if it is stored in 8000 memory location. So in your exam, this type of question can be this may become like what, draw the timing diagram. You can write it. Okay, if you have pen and paper with you, you can write it. What will be the question? This type of question, how it comes. So draw the timing diagram of move A comma B instruction. Draw the timing diagram of move A comma B instruction stored at 8000 memory location. I repeat, draw the timing diagram of move A comma B instruction stored at 8000 memory location. Okay, so you just need to draw this diagram. You don't need to write anything else. You don't need to write it in details, everything. Okay, just draw the diagram, specify the signals, and we'll get the full marks. Okay, 5 or 6 marks is there, that will be here. So you don't need to discuss anything else except this timing diagram drawing. Okay, you just need to draw this diagram. Okay, now is it clear? Any doubt regarding this? Do you have any queries? Any doubt? Do you have any queries, any doubts? You can ask me now so that I can clear you the concept and move. Okay. Okay, so move on to the next slide or next example, which is based on the MVI related instruction. So MVI related instruction. Now for MVI, can anyone tell me the function of this instruction, MVI B comma 3F, which is written over here? Anyone? What is the function of MVI B comma 3F instruction?
That it instructs to
immediately.
to move immediate the 3F data to the registered B.
Yes, very good, very
Yes.
good, good. So so it is assume this one is stored in 8000 memory location. Okay, or 8050 memory location. 8050 memory location. What is written? MVI B comma MVI B comma 3F. Now, what is the size of this instruction? Is it a 1 byte or 2 byte or 3 byte instruction? MVI B comma 3F?
1 byte, sir.
No, it's a 2 byte instruction because it has two parts. One is the opcode and is the operand. Now to load this opcode, you need one memory location, and to load this operand, you need another memory location. That's why it's a 2 byte instruction. Okay. So the code of machine code of this particular instruction is for MVI B, it is 06. MVI B is 06. Okay, and then you have the data which is 3F. Now 06, 3F, all these are 8-bit in size. Now according to the structure of memory location, each memory can store maximum 8-bit of data. Okay, so it is an 8-bit number, it is another 8-bit number. Okay, now to store this 8-bit of code or data, you need one memory location. Now to store this another data, you need another memory location. So two consecutive memory locations are required. That's why it is a 2 byte instruction. So at 8050 memory location, memory location, what will be stored? First 06 will be stored. And what is that? That is the opcode of this instruction. And what do you mean by opcode? Which operation is to be performed, and where it, so in this case, which operation is to be performed? Move operation immediate to B register. Okay, so 06 will be stored over here. Now next memory location, it is required to store the data part or operand part. So 8051 memory location. So here what you need to store? 3F. Okay, so can you tell me how many machine cycles are required for this timing diagram of MVI B comma 3F? How many machine cycles are required? Machine cycle means how many machine cycles are there total? Either so opcode fetch is one type of machine cycle, memory read is another type of machine cycle, memory write is another type of machine cycle, IO read is there, IO write is there. So these 5 types of machine cycles are there, but it depends on that particular instruction execution or the function which machine cycle is required for which instruction. So according to this function of this instruction, anyone can you tell me the first what will be the first machine cycle?
Output fetch.
Opcode fetch. So opcode fetch machine cycle is required to fetch this 06. So it is called opcode fetch. Opcode fetch machine cycle. Now after fetching the opcode, when microprocessor identifies, okay, this is the operation code, I need to perform that operation, then it demands for which one? It demands for that particular immediate data which it is needed to load it inside the B register. Okay, so at that time the next machine cycle will be your memory read, because this data, it is stored in some memory. So if memory read is to be performed, then memory read machine cycle is required. So the next machine cycle will be memory read machine cycle. Okay, so how many T states are needed for opcode fetch machine cycle? 4 T states. To perform the opcode fetch machine cycle, it needs 40 states. And to perform the memory read machine cycle, it is fixed, which is 3 T states are required. 3 T states. Okay, so there are 2 machine cycles. First one is opcode fetch machine cycle. Second is memory read machine cycle. Opcode fetch machine cycle requires 40 states to execute it, and memory read machine cycle requires 3 T states. Okay, now coming back to that slide. here. So MVI B, 3F. The first machine cycle is opcode fetch machine cycle from this position to this position. Okay. Then when opcode fetch is over, the next machine cycle will be memory read machine cycle. So every machine cycle you need to draw it side by side. Okay, one after another. And what will be the graphical format? It will be just like same type of signals. Okay, like first this one, so it needs opcode fetch needs 40 states. So this is T1, T2, T3, T4. Next memory read machine cycle requires 3 T states. So T1, T2, T3. Okay, now starts from this position. So how many signals are required? These signals are required for every timing diagram. What are they? The higher order address bus A8 to A15, lower order address, multiplex address and data bus AD0 to AD7, signal ALE signal, status signals, IOS plus M bar, S1 and S0, and one control signal, whether it is read or write based on the function. Okay, so it needs so basically the code 06, which is the opcode. So this is fetched from the memory location 8100. Here it is assumed that it is stored in 8100. I have assumed that it was stored in 8050. No problem. Okay, according to your assumption, this, if it is not given in your problem statement, then you can assume any memory location. Okay, and that memory location will be transferred in this way. Lower order will be processed through lower order address bus, and upper 8-bit address will be transferred through 8-bit up higher order 8-bit memory address bus. Okay, so now this code is fetched from this memory location when this read signal goes low and when this ALE signal goes low, and it will be fetched from this memory location to the instruction register. So it will be stored in instruction register. Now from instruction register it goes to the instruction decoder circuit, where it is decoded and interpreted by interpreted so that it can understand which operation is to be performed. Then it demands for the operand part, and to fetch that or to read the code or to read the data, to read the operand, you need to access the next memory location, which will be in this case 8101. Okay, the first one 8100, so the next memory location will be 8101, and at 8101 what is situated over here? The operand or the data which is to be moved to the B register. Okay, so the second machine cycle is the memory read machine cycle, where the operand 3F, that is read from the memory location 8101 using the memory read machine cycle. Okay, so that will be also performed. So every read, as you can see in this picture, this timing diagram of every instruction, every read operation will be performed between the middle of T2 to the middle of T3, whether it is opcode fetch or memory read, or if it is write. So every control main operation will be performed between the middle of T2 to middle of T3. Okay, and why it is not included in T1? Because T1, it is used to first transfer the address. Without knowing the address, how microprocessor can fetch or read the data from that particular address? So always microprocessor first needs to identify the address. Okay, then from that address the particular data can be fetched or can be written into that particular memory location. The data can be written. Okay, is it clear? Any doubt? Any doubt? Is it clear?
Yes, sir. Sir, একটা প্রশ্ন ছিল স্যার,
Yes.
এক্সাম রিলেটেড স্যার, এক্সামে স্যার একটু সাজেশন যদি দিতে পারেন স্যার ভালো।
দেখ আগে তো ক্লাসই করলে না, এখন এক্সাম সম্বন্ধে ভাবার তো দরকার নেই। সাজেশন ক্লাসটাই সাজেশন, রোজ ক্লাস করো, হ্যাঁ, তাহলেই পেয়ে যাবে তার মধ্যেই সাজেশন। যদি ভালো করে খেয়াল করো যে আমি কি বলছি, তার মধ্যে কিন্তু সাজেশন দেওয়া আছে। সেই জন্য ভালো করে শোনো, তাহলে বুঝতে পারবে যে কোনটা আমি দিলাম আর কোনটা দিলাম না। অলরেডি আমি একটা কোশ্চেন দিয়ে দিলাম প্রথমেই, যদি তোমরা খেয়াল করতে পারো তাহলে দেখবে যে আমি সেইগুলোই তোমাদের লিখতে বলবো যেগুলো দ্যাট ইজ মোস্ট ইম্পর্টেন্ট ফর ইউর এক্সাম। Okay, it may be some concept, maybe some tricks, maybe some question, so that is the suggestion actually. Okay, follow this class and you will get the right suggestion. Okay, leave it. Tell me any doubt regarding this timing diagram. Forget about exam. Right now you are doing the class, so if you have any class lecture related problem, you can ask me now.
No problem, sir.
Huh? Is it clear?
Yes, sir.
Yes, sir.
This opcode is generated from what we have seen in the GNUC software, that in that list option, there the opcode is generated. Will it that, sir?
Every instruction has its opcode. Okay, you don't need to generate it, it is already generated. Okay, so assembler is used, so so machine code, that opcode is already given, you don't need to generate yourself, it is already predefined opcode. Okay, operand can be given at any time, you can change the operand as per your requirement. Okay, in that simulator there is an assembler which assembles every machine codes, well, assembly language to machine language, it is converted. Is it clear? Anything else? Any doubt? Okay, so move on to the next one. The next example is a 3-byte instruction example. STA 9000. STA 9000. Now, suppose it is stored in memory location 800F. 800F. Okay. Suppose it is stored in 800F. In this memory location, there is an instruction called STA 9000. So what is the function of this instruction? Store the accumulator content into 9000 memory location. Okay, store the accumulator content into 9000 memory location. So memory locations and register both are used to store the data. Okay, it's just like your pockets and the bag. Okay, so the limited number of pockets in your trouser, but so limited number of things you can put it over there, keep inside that. So you have limited number of registers here also. So registers are just like your pockets. Okay, memory location, so huge memory location is there, that is 64 kilobytes of memory location. So in this memory location, how many memory locations are there? 65,000 memory locations. So huge memory space is there. Okay, it's just like your bag. Inside your bag you can keep more valuable things. Okay, but in your pocket, inside your pocket, which things you need to keep inside your pockets? The things which are required often, frequently, these are used, like your mobile phone, like your purse. Okay, because it is easy to access. So registers are same. So registers are inside the processor. So if anything is stored inside the processor, inside the register, it is easy to access. It takes less time to access. And if anything is stored inside your bag, and you just keep that thing from your bag, it takes more time. It's just same concept over here. If any data is stored inside memory location, so memory locations are outside of the processor, it is external, so it takes more time to take that data. So here it also we need to perform the result. We need to perform the storing operation, store the accumulator content into some memory location. Now it's a 3-byte instruction. Okay, there is a particular opcode for STA. What is that? If STA opcode is 32, the STA opcode is 30, machine code is 32. Okay, all these are in hexadecimal number system. I have not written over here H. Okay, you can easily understand this 32, it is in hexadecimal number system. So the opcode of STA, the machine code or opcode of STA is 32. Now after this opcode, you have the operand part. What is that? The 9000. So 9000, what is the size of 9000? It is a 16-bit number. It is a 16-bit number. So you can't load any 16-bit number at a time, because it is an 8-bit processor. It is an 8-bit processor. So every operation will be based on 8-bit operation. Okay, no 16-bit will be processed at a time. That's why you need to divide this 16-bit into certain category, like it is divided into two 8-bit portion. The lower 8-bit will be processed first, 00. Then you have the upper 8-bit, which is 90 over here. Now from this structure, to load this code or data, whatever, it is 8-bit in size, you need one memory location. Next, this 8-bit of code, you need another memory location. Then next 8-bit of code, you need another memory location. So consecutive 3 memory locations are required to store the entire instruction. Now to store into this memory location, STA 9000 means to store 320090, the same thing. So this is called assembly language, this is called machine language. It is identified by user or programmer or human being. It is identified by a machine or the processor. Okay, so if the starting memory location for this one is 800F, so 32 will be stored in 800F memory location. Then the next memory location will be, what will be the next memory location? Can anyone tell me what will be the next memory location after 800F?
8010.
8010. Good, 8010. So the next memory location will be 8010, where the 00 will be stored. Then the next memory location will be 8011. 8011. Okay, so 3 consecutive memory locations are required to access. Now move on to the slide again, so that you can understand the timing diagram of this instruction. Okay, one thing, no, I have to tell you another thing also. Okay, so to fetch this code. What is that? Opcode. So opcode fetch machine cycle will be required as your first machine cycle in this case. So this is opcode fetch machine cycle. Okay. Now what will be the next machine cycle for this one? Next machine cycle for this one? Anyone? Is it memory read or memory write or IO read or IO write? Which one? This is memory read machine, memory read machine cycle. Good. Okay, so what will be the next machine cycle? Next machine cycle will be memory read machine cycle. Is it visible properly?
Yes, sir, visible.
Okay. So this is one memory read machine cycle to identify the lower 8 bit of your memory address. Then what will be the next memory next machine cycle? What will be the next machine cycle? It is
Memory read.
again memory read. Okay, because 16-bit memory address is divided into 8-bit to 8-bit form, so that if the first one is your first memory read, now for upper 8-bit identification purpose you need another memory read machine cycle. Okay, now address is identified. Now is it over? Is it finished? No, the ultimate operation, the actual operation is still pending. It is still remaining. What is that?
Memory write.
Yes. This is the last thing will be your memory write. So what is the last operation? From internal to external. If you can remember it, I have already told you in earlier classes that if anything is transferred from internal to external, that is called the write operation. And where it is transferred? It is transferred to memory. So the last machine cycle will be your memory write machine cycle. Memory write machine cycle. So how many machine cycles are required for STA? You need 4 machine cycles. First one is opcode fetch, second is memory read, third one is again memory read, and the last one is memory write. Why it is so called memory write? Because from accumulator the result will be stored into this memory location. Memories are external to the processor, so that is if anything is coming from internal to external, it is called write operation. Okay, and just opposite to this one, if anything is going from external to internal, it is called read operation. Just like in this case for MVI, it is loaded inside the B register. That's why the cycle was memory read. Okay, but here it is going from register to location. That's why the cycle is memory write. Is it okay? So move on to the slide. Here 4 machine cycles are required. The first one is opcode fetch, which needs 40 states. Memory read machine cycle, which needs 3T states, and against the second memory read it needs 3T states, and memory write it also needs 3T states. So the address, the lower order address is 0F, upper is 80, so that it can, the combinations of these two 8-bit and 8-bit, it can create 800F memory location. From this memory location 32, that is the opcode of STA, is fetched. And when this will be fetched? When this read bar signal gets activated. And when this read bar signal gets activated, when ALE signal gets disabled. And at the middle of T2 to middle of T3, the read operation is to be performed. and after that it will be unspecified, the last T state. Next, when this opcode is fetched and it is decoded, executed by the processor, after that it needs to identify which memory location, to which memory location the result will be stored from accumulator. So microprocessor needs to identify that particular memory location. And how this memory location can be identified? That's why the next memory address will be 8010, where the lower 8 bit of that memory address is to be loaded, and next memory address is 8011, where the upper 8 bit of your memory address will be loaded. And when this memory address is identified by the processor, the actual operation, now the memory address is 9000, where this 3F is to be written, and that's why the write signal goes activated over here. And all these are read signal, so it is a read operation, so that time a read signal is activated. At the last cycle it is a write operation, that's why the write signal gets activated. And for each machine cycle, the record number of combinations will be in this way: 011, 001 for read operation, and 010 for write operation. Is it clear? Tell me, is it clear up to this much? Is there any confusion?
No, sir.
Okay, there is an in instruction, so I will not discuss in instruction here. So you need to understand by examining this yourself. I will load it in Google Classroom. If you need to understand in your own way. If you have any confusion, you can ask me on next day. Okay. Next is INR M. So in and out, that must be cleared by yourself. If you have any confusion, you can ask me on next day. Okay, but try to understand it. INR M. INR M means increment the content of memory location. What is M? Is it a register? No, it's an indirect memory location. Why it is so called indirect? Because it is always pointed by HL register pair. If you can remember it, I have told you in earlier classes that M is always applicable with HL register pair. So M is the memory location which is pointed by HL register pair, and the content of that memory location will be incremented if INR M is executed. Now after incrementing this content, where it will be written? It will be written into the same memory location. It will be written Prayash Kumar Saha, roll number 54, mute yourself.
Yes, sir. Sorry, sir.
So what I am telling you, memory. The function of this instruction is increment the content of memory location, by 1. Now if the memory location is suppose 9001, I need to share it again. Suppose at 9001 I have one content which is 12. Now how can we increment this content by 1 so that we can get the result as 13 in this memory location, in the same memory location? After getting incremented by 1, it will be stored in same memory location. So my aim is to get the data as 13. This is my N. And how can you do this from 12 to 13? If INR M is to be executed, increment the content of memory location which is pointed by HL register pair. Now how this HL register pair can be pointed? By using LXI H instruction. LXI H instruction. LXI H comma LXI H comma 9001. Okay, so HL register pair holds this memory address where some data byte is there. What is that data byte? 12. So HL register pair holds this 9001 only. So if it is your HL register pair, this one is your H, this one is your L. So it stores 9001. HL is not used to store the 12. It is used to store the 9001. Okay. So it is a memory location where some data byte is stored, and the data byte is 12 over here. Now if INR M is to be executed, it will be 13 and it will be written into the same memory location. So now can you tell me what will be the, how many machine cycles will be there for INR M? If it is stored in, suppose 8100 memory location, 8100 memory location our A instruction, this instruction is stored. So it's a 1 byte instruction, but it needs more than one machine cycle. Okay, so first one will be the opcode fetch, obviously. So opcode fetch machine cycle. So 8100 কি স্টোর হবে INR M. INR M এর মেশিন কোড কত? It's maybe I think 34. 34 is the machine code for INR M. Okay, so this is called opcode fetch machine cycle. Now is it finished? No, because it's just only opcode fetch machine cycle, means which operation is to be performed. Now what is the operation is to be performed? To get the data increment by 1. Okay, but before incrementing that data, you have to identify the data. And how microprocessor can identify the data? If memory location is identified properly, in that memory location there is a data. So it's an indirect memory location which is to be performed by one single machine cycle, and that is called, next machine cycle will be called memory read machine cycle. Using that memory read machine cycle, the data can be identified, and when this data can be identified, it will be incremented by 1, and then again it is written into the same memory location. So what will be the next memory location machine cycle? What will be the next machine cycle? Last or final machine cycle will be, anyone? What will be the last machine cycle? After incrementing this data by 1, it will be stored into the same memory address 9001. So what will be the machine cycle name? Is it a
Right.
memory write? Memory write machine cycle. So 3 machine cycles are required. The first one is opcode fetch, second is to get the data, and third is to increment the data and storing that data into the same memory location. Memory write machine cycle. So 3 machine cycles are required. Now move on to the slide. This one. First one is the opcode fetch machine cycle. The same type of graphical representations are there over here. So read operation will be performed between the middle of T2 to middle of T3, where the opcode of INR M 34 is fetched and executed by the processor. After executing this opcode, it needs to identify the data. And where is the data? At 9001 memory location. 9001 memory location. Okay, so from this memory location, data is over here. It is read by the processor, and when it is identified by the processor, it is to be incremented by 1 and stored it into the same memory location. That's why this cycle is called memory write. And at some memory location, the data will be incremented by 1 from 12 to it gets 13. Okay, so first machine cycle, second machine cycle is based on your read operation status, and third machine cycle is based on your write operation status. So according to the status of each machine cycle, the record number of signals will be given over here. 011, that is for opcode fetch. Memory read is for 001, sorry, 010, and memory write will be 001, because the status signals are interchanged the positions. IO slash M bar S1 and S0. Okay, I have mentioned that table in according to this order: IO M bar, then S1, then S0. Okay, if this order has to be mentioned, IOM bar S1 S0, then the opcode fetch machine cycle will be 011, memory read machine cycle will be 010, and memory write will be 001. Okay, so please check everyone whether it is right or wrong. So that is the timing diagram of INR M. Now that's all for today. If you